Welcome. In this video presentation, we'll walk you through the process of upgrading legacy barcode objects. During the presentation, we'll cover 4 key topics. First, we'll examine the legacy barcode types available. Next, we'll identify which extended barcode types have replaced these legacy versions. Then, we'll discuss important considerations to review before beginning your upgrade. Finally, we'll demonstrate how to upgrade multiple legacy barcodes in practice. Developed and introduced in the late 1990s for the Formscape product, the legacy barcode object offered a limited but widely used selection of barcode symbologies. Let's review the types available in the legacy barcode object by summarizing the information from the Transform help pages. Code 39. Widely used in government applications and industrial identification, Code 39 is a variable length, bidirectional, alphanumeric symbology. Please note, any lowercase characters are automatically converted to uppercase to ensure compatibility with the symbology's input data requirements. Code 128 is used in industrial applications and for inventory purposes, and is a variable length, continuous, bidirectional, alphanumeric symbology. It supports 3 different code sets, where Set A supports uppercase characters and ASCII control characters. Set B, which supports both uppercase and lowercase characters. And Set C, that supports double-density numeric characters. Please note that the legacy barcode object implemented Set B. Interleave 2 of 5 is widely used for inventory, warehousing, and industrial applications. It's a variable length, continuous, bidirectional numeric symbology. This symbology encodes only data containing an even number of digits, including the optional checksum. Please note, since the barcode input data must contain an even number of numeric characters, a 0 is automatically inserted at the start of the input data if it only contains an odd number of characters. Codebar is commonly used for inventory control, libraries, and photo finishing. It is a variable length, discrete, bidirectional numeric symbology that must contain start and stop characters. Please note, if no start-stop character is supplied in the input data, the legacy barcode object automatically wraps the input data with the start-stop character A. UPC, Universal Product Code, is a standard used for retail and consumer products. It is a fixed-length, discrete, bidirectional numeric symbology. The symbol is separated in half by a center guard and enclosed on either side by guard bars. UPCA has a fixed length of 12 digits. Users can supply 11 digits, and an automatic checksum is appended as the 12th digit. Please note, if Use Checksums is enabled in the legacy barcode properties and the raw data length exceeds the maximum number of digits, the data is truncated and the checksum is calculated using the truncated data. And if the data is less than 11 digits, it is padded with zeros from the start, and the checksum is calculated from the final padded data. EAN, European Article Numbering System, is a superset of UPC. It is a fixed-length, continuous, bidirectional numeric symbology. EAN 13 encodes 13 digits, including a checksum. Users supply the first 12 digits to be encoded. Please note, just like the UPCA symbology, if the input data length exceeds the maximum, the data is truncated and the checksum is calculated using the truncated data. If the data is less than required, it is padded with zeros from the start, and the checksum is calculated from the final padded data. EN8 is the same as EN13 but only accepts 7 digits plus 1 check digit, and as such is a shorter version used for very small items, where the EN13 barcode just won't fit. Like UPCA and EN13, the legacy barcode object automatically truncates or pads the input data to the required length. The EN128 symbology is a versatile barcode standard for trade and industry, ideal for labeling goods and pallets. It is based on code 128 and is distinguished by a special FNC 1 character immediately following the start character. It offers flexible data encoding, allowing for multiple pieces of information, such as product codes, weight, or expiration dates, to be combined in a single barcode using standardized application identifiers. And it can be variable in length, supporting up to 48 data characters, including AIs and FNC1 separators, with a maximum physical length of 165 millimeters. The final barcode type available in the legacy barcode object is the postal numeric encoding technique, PostNet, which provides identification of zip code information on letter mail. The bars and spacings are of a fixed size. Valid barcode input data should contain 5, 9, or 11 numeric digits. Please note, this has been replaced in the extended barcode object by 3 individual types: the USPS PostNet 5, 9, and 11 barcode symbologies. Let's now take a look at which symbologies you should use in the extended barcode object to replace those legacy ones. The extended barcode functionality uses the Tech IT Barcode Library, T-Barcode 11DLL, which provides comprehensive barcode support with enhanced features. The table below shows which extended barcode symbology to select when migrating from each legacy barcode type. Code 39 can be replaced by code 39 or code 39 full ASCII. Code 128 can be replaced by one of the following symbologies. Code 128. Code 128, subset A. Code 128, subset B, which is the subset used in the legacy version. Or code 128, subset C. However, code 128 should be fine, but we strongly recommend that you print and check that the barcode content reads as before. Interleaved 2 of 5 is replaced by 2 of 5 interleaved. Codabar is replaced by Codabar 2 widths. UPCA can be replaced by UPCA plus 2 or 5 digits. YAN 8 can be replaced by YAN 8 or plus 2 or 5-digit variants. YAN 13 can be replaced by YAN 13 or plus 2 or 5-digit variants. YAN 128 can be replaced by YAN 128 or YAN UCC 128. And PostNet can be replaced by the USPS PostNet variants. When planning to upgrade legacy barcodes, there are a number of considerations you need to be aware of before you begin your upgrade project. First, and most importantly, to upgrade branch files containing legacy barcodes, you must use the 32-bit version of Transform 8.3, as the 64-bit version does not support legacy barcode objects. If you open a branch file with legacy barcodes in the 64-bit version of Transform Designer and switch to the branch view, the barcode legacy object will appear on the branch as an unknown object type and will not appear in the Find Tools Legacy Objects list. In fact, when upgrading repositories that contain any legacy objects, we recommend using the 32-bit version of 8.3 to ensure legacy object compatibility with previous versions. Before replacing legacy barcodes with extended barcodes, you must review the following legacy barcode options and features that are not directly compatible with their extended barcode equivalents. Let's start with the barcode quiet zone. The legacy barcode automatically calculates the barcode quiet zone around the code within the bounding box on the form, while the extended barcode offers greater flexibility, giving you the option to configure your own quiet zones. Here you can see the legacy barcode automatically adds white space around the barcode inside the blue bounding box. However, if we look at the same barcode using the extended barcode object, it scales the code to the size of the bounding box, as by default it does not add a quiet zone. So you need to take care when replacing the legacy barcode using the same bounding box that it doesn't overlap other objects on the form, which could render the barcode unreadable. The legacy barcode default behavior is for a checksum to be calculated automatically based on the symbology's check digit, and will be encoded from the valid raw data. For those symbologies where checksums are optional, this can be switched off. If the barcode data exceeds the maximum length, the data is automatically truncated, and the checksum is then calculated using the truncated data. But if the data is less than the required length, the data is padded with leading zeros, with the checksum being calculated from the final padded data. Here you can see the legacy barcode EN8 automatically truncating the input data 12345678 to the valid 7-digit input 3456789, which is then encoded to 3456789. If we select the legacy EN13 barcode type, but only supply 9 digits, it automatically pads the input data with 3 leading zeros to achieve its required 12-digit input value and is encoded to 0001234567895. However, if we attempt to use the same input data and barcode type, the extended barcode does not draw the code, but draws a gray rectangle to indicate the data did not meet the symbology's requirements. It's important to note that by default, the extended barcode object does not attempt to truncate or pad invalid data. The legacy barcode rotates with the parent form, but the extended barcode doesn't. In the example shown, you can see a legacy barcode displayed in black and an extended barcode in red on the Transform Designer page view. When we perform a print preview, you can see that both codes are displayed in the correct orientation. However, if we navigate to the branch and change the form rotation to 90 degrees, then go back to the page view and perform another print preview, you can clearly see that the legacy barcode rotated with the form, but the extended barcode did not. To resolve this issue, you need to manually rotate the extended barcode. In this example, since the form is rotated by 90 degrees, we need to rotate the extended barcode by 270 degrees. While this looks incorrect on the page view, when we run the print preview again, you can see the barcode has been rotated correctly. So, depending on the parent form rotation, you will need to manually rotate the extended barcode on the page view using the rotation properties detailed in the table. This ensures you maintain the correct final print output orientation. We always recommend performing a print preview to visually confirm that the barcodes will print correctly. Now we're going to demonstrate upgrading legacy barcodes, replacing different barcode types, using best practice along with some useful tips and tricks that you can apply when upgrading your legacy barcodes. In this demonstration, we'll upgrade the barcodes on a label containing several different barcode types. Code 128 will illustrate the differences between the legacy barcode using subset B and the extended barcode's default code 128 symbology. Code 39. This example demonstrates why selecting the correct check digit is essential to match the legacy barcode's checksum option. UPCA will show how the legacy barcode automatically truncates and pads data, then explain how to replicate this behavior using the extended barcode. And finally, interleaved 2 of 5, another demonstration of why choosing the correct check digit really matters. Let me hand you over to Andrew for the demo.
Thanks. Now let's walk through this together. Open Transform Designer 8.3. Important note here, for legacy object compatibility, we are using the 32-bit version for this demonstration. First, we open the branch file. Once open, you'll receive a pop-up notification. This is because the file contains legacy objects. The pop-up serves two purposes. It alerts you to the presence of these legacy objects, and it directs you to use the Find tool. This tool will help you identify exactly where these legacy objects are located so you can proceed with upgrading them. Okay, let me walk you through this process. From the View toolbar, select the Find tool. Then, within the Find window, select Objects Legacy. Choose the Find result window you'd like to use and click Find. This action opens the Find window, which by default will dock at the bottom of your screen. Here, you'll see the legacy objects organized by type. You can expand each type to view the object's path within the branch structure. In this example, it found 4 legacy barcode objects. So let's go ahead and replace them. Since we're working with drawable objects, we first need to open the Page Design view. In the Assistant window, click on the link, Go to Page Editor to work on the output design. This will open the Pages view. Since our design includes other drawable object types alongside the legacy barcodes we need to replace, we can take advantage of the Filters Lock option to prevent accidentally selecting or moving those other objects during the replacement process. In the Filters window, lock the text, line, and picture object types, leaving the Barcode Legacy option unlocked. Once locked, adjust the Lock Transparency slider to hide the locked objects. This allows us to focus exclusively on the barcodes we're working with. Before we replace the legacy barcode, let's first review its properties. Select the barcode and open the Properties window. In the top right corner, click on the Advanced Properties tool. Here, you should note the legacy barcode settings. In this example, we can see the symbology used is code 128. The orientation is set to horizontal, and human readable is set to none. When upgrading a legacy barcode, the recommended approach is straightforward. Simply copy the legacy barcode, position your mouse pointer where you want the copy placed, and paste it. Next, right-click on the pasted barcode and select Show Tree Object. This takes you directly to the Barcode Legacy object on the branch. Before replacing the object, we need to preserve the input data. Copy the input to your clipboard. Now, open the Object palette and search for Extended Barcode. Drag the Extended Barcode object onto the Barcode Legacy object to replace it. Finally, paste the input from your clipboard over the Input Text Child object to restore your data. If we navigate back to the page's view, you'll immediately observe that the barcode automatically scales to fit its bounding box without incorporating a quiet zone. This is one of the considerations raised by Emma. Our first task is to resize the extended barcode. We'll carefully adjust its dimensions until it corresponds precisely with the legacy barcode positioned below it. Now that we've aligned the two barcodes, you'll notice something interesting. The bars don't match up. This discrepancy occurs because the two barcodes are using different symbologies. To resolve this, we need to open the Advanced Properties. Locate the barcode type option and change it to code 128, subset B, to match the symbology used by the legacy barcode. Confirm your selection by clicking OK. For our final step, drag the extended barcode directly over the legacy version. Then, select the legacy barcode and delete it. This leaves us with a single, properly configured extended barcode that maintains the correct formatting and symbology. Now that we've successfully completed our first barcode replacement, let's apply this same methodology to the remaining barcodes on our form by following these structured steps. Step 1. Duplicating and accessing the barcode object. Begin by copying and pasting the legacy barcode. Once you've created this duplicate, right-click on it and select Show Tree Object from the context menu. This will reveal the pasted copy of the object on the branch. Step 2. Replace the barcode object. Within the Tree Object view, copy the input value. Then from the Object palette, drag the extended barcode onto the Barcode Legacy object to replace it. Paste the input onto the Input Child Text object. Then navigate back to the page's view to continue our work. Step 3. Documenting the legacy barcode settings. Select the legacy barcode and open its Advanced Properties to note its current configuration. The barcode symbology is set to code 39. The Use Checksums option is active. Human readable text is set to none. Then click OK to close this dialog. Step 4. Matching the extended barcode configuration. Now select the extended barcode and open its Advanced Properties. Our goal here is to configure it to match the legacy barcode settings, so we change the barcode type to code 39. Step 5. Aligning the barcode dimensions. Proceed by adjusting the size of the extended barcode until it aligns precisely with the legacy barcode position beneath it. Step 6. Addressing the checksum discrepancy. You'll observe once again that the bars don't align properly. This time, however, the cause is different. The legacy barcode was configured to use checksums, which means we need to add a corresponding check digit to our extended barcode's Advanced Properties. Step 7. Researching the correct check digit. Since the extended barcode utilizes the TechIT DLL, we'll need to consult their technical documentation. Open your preferred web browser and browse to the TechIT Knowledge Base overview pages. Locate the code 39 linear barcode symbology within the reference table. Take note of the optional check digit specification for code 39. This is modulo 43. Step 8. Applying the check digit configuration. Return to Transform Designer and select the extended barcode. Open its advanced properties, then navigate to the Advanced tab. Change the check digit setting to modulo 43 and confirm by clicking OK. Step 9. Finalizing the replacement. For our final step, position the extended barcode directly over the legacy version. Then select and delete the legacy barcode. Let's go ahead and replace the next barcode, following our structured steps. Step 1. Duplicate and access the barcode object on the branch. Step 2. Replace the barcode object as we did before, remembering to copy the input data before we replace it. Step 3. Document the legacy barcode settings by noting the following configuration. The symbology is set to UPCA. The Use Checksums option is active, and human-readable text is set to encoded. Step 4. Match the extended barcode configuration by changing the extended barcode symbology to UPCA and enable the print text option. Then click OK to commit the change. However, you'll notice something unexpected has happened. Instead of rendering the barcode, the extended barcode is displayed as a gray rectangle. This gray rectangle indicates that the barcode input data is invalid. Let's investigate why this is occurring. Navigate back to the branch and select the Input Data Container shortcut to examine the value it's mapped from in the data palette. For the UPCA symbology, the input should be 11 digits. In this particular example, however, the data is 13 digits in length, which doesn't meet the extended barcode symbology's required format. This behavior actually demonstrates that the extended barcode is functioning correctly. When input data is invalid, the barcode appropriately refuses to display, preventing potential scanning errors. But as Emma explained earlier, the legacy barcode employs a different approach to this scenario. When the checksum option is selected, it implements an automatic data correction process. It truncates or pads the input data to the valid number of digits, and then calculates the checksum based on this corrected fixed-length data. To replicate this legacy behavior, we've created a branch that can truncate or pad input data, ensuring the input conforms to the required number of digits. You will need to ask your Transform consultant to provide the branch or create it and copy it into the repository. If you wish to integrate this solution to match the behavior of the legacy barcode, navigate to the repository window. Locate the branch we've prepared for this purpose. In this instance, it's labeled barcode checksum, and drag this branch directly onto the input child, which will create a branch shortcut. Next, expand the branch shortcut to reveal its parameters. Click on the barcode symbology text child object and enter UPCA. You'll then observe that the input data has been truncated to the required 11-digit format to conform to the UPCA input data specification. Now we're ready to complete the replacement process. Navigate back to the page's view and complete the remaining step by adjusting the extended barcode size accordingly and positioning it over the legacy barcode before deleting the original. Okay, just one more to replace. Again, we will follow our structured steps. We'll start by duplicating and navigating to the object on the branch. Then we replace the barcode legacy object with the extended barcode. Next, we take note of the current legacy barcode settings. The symbology is set to interleaved 2 of 5. The Use Checksums option is checked, and human-readable text is set to encoded. Then we change the extended barcode symbology to code 2 of 5 interleaved and enable the print text option. Adjust the size and position of the extended barcode. Again, you'll notice the bars and printed text do not match due to the Legacy Barcode Checksum option being active. Refer to the Tech IT documentation page and take note of the check digit used for code 2 of 5 interleaved, which is modulo 10. So we need to select the extended barcode check digit from the Advanced properties, navigate to the Advanced tab, and change the check digit setting to modulo 10. Finally, we make the necessary adjustments to the extended barcode size before positioning it over the legacy barcode and deleting the original. Let's return to the Filters tab and remove the locks we placed on the other drawable objects earlier. This will make them visible again on our form. Next, we'll zoom out to view the full page. This allows us to verify that the extended barcode isn't overlapping with any other objects. This is important as by default the extended barcode is not transparent whilst the legacy barcode was. Finally, refresh the Find window to confirm that we haven't missed any legacy objects. We have now successfully replaced all the legacy barcodes within this branch, and our upgrade process is now complete. Let me summarize the key takeaways we've covered. For preparation, you should always utilize the filter tools to lock other drawable objects before beginning your replacement work. This prevents accidental modifications, whilst being able to make them invisible using the lock transparency setting. Use reference materials by keeping the Tech IT documentation pages open throughout your process. This allows you to quickly reference the specific check digits required for each barcode symbology you're working with. Consider data handling strategy. Determine in advance whether you want to replicate the data correction functionality of the legacy barcode system, particularly its automatic truncating and padding of input data. This decision should align with your organization's requirements on whether Transform should only present the data provided or modify it to match the barcode input data requirements. And finally, visual verification. Perform thorough visual checks by layering the legacy and extended barcodes. This stacking technique allows you to directly compare whether the bars align properly, a simple but effective quality assurance method. If you follow the systematic approach presented in this demonstration, we're confident that you'll be able to successfully complete your legacy barcode upgrades with accuracy and efficiency. Thank you for your attention. And now, let me hand you back to Emma.
Thanks, Andrew, for that comprehensive real-world demo. It was really great to see how to replace different barcode types and how to configure the extended barcode settings to match the legacy barcodes. If you need some help with upgrading, don't worry, you're not alone. Your regional bottom-line office are just a phone call away, and they would be more than happy to chat about your upgrade process. The team there can arrange a meeting with you to walk through everything, whether you're just starting to think about upgrading, or you're halfway through and hit a snag. We appreciate that no two projects are the same, so sometimes having those bottom-line experts in your corner can make all the difference. They can offer tailored advice to help make your upgrade a success. We would both like to thank you for taking the time to watch this video, and we wish you every success on your upgrade journey.